So if the elements are arranged along a closed curve like a ring or a circle, such a permutation is called as a circular permutation. Just find out the number of permutations of principal, vice principal and the dean, that's equal to 3 factorial, and the remaining staff members 15 minus 3 is 12 with the clockwise direction and the anti-clockwise directions are not distinguished. Then the number of circular permutations of n objects is equal to n minus 1 factorial divided by 2. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. In my previous class, we have discussed regarding arrangement of letters. So, permutation for arrangement of letters when the condition, when the repetitions occurs and repetitions do not occur, with repetitions and without repetition. Now, in this session today I am going to discuss regarding circular permutations, very important concept, that is circular permutations and important formulas on circular permutations and the problems related to the circular permutations, right? So, we have studied regarding linear permutation. Now, in this session, I will take one example for linear permutation and then also the example for circular permutations. Now, let us know regarding what is circular permutation. Circular permutation means when the objects are arranged, along a closed curve like a circle or a ring. So, when the objects are arranged along a closed curve like a circle or like a ring, then the permutations are known as the circular permutation. So, if the elements are arranged along a closed curve like a ring or a circle, such a permutation is called as a circular permutation. Now, let us take an example. Consider the arrangement of numbers A, B, C, D. So, A, B, C, D can be arranged in a circle A, B, C, D. So, you can join like this. So, the closed curve. Arrangement of these in a circle. This is an example for a circular permutation. So, here how many ways we can arrange? So, A, B, C, D. Now, let us start from this. A, B, C, D. Again, A, B, C, D. Again, A, B, C, D. A, B, C, D. So, like this we can arrange the elements A, B, C, D in a circle or a closed ring. But in circular permutation, however, we can arrange they are same, that is number of permutations is equal to 4 factorial divided by 4, that is nothing but equal to 3 factorial. So, that means, but in circular permutation the arrangement can be equal to 4 factorial divided by 4, that is equal to 3 factorial. In general, what is the general formula for this? That means, since there is neither being nor an n for a circular permutation of n objects can be arranged in n minus 1 factorial. So, n objects can be arranged in n minus 1 factorial. If the clockwise and anti-clockwise orders are not distinguishable, then the number of circular permutation is nothing but n minus 1 factorial divided by 2. So, the number of circular permutations of n objects can be arranged in n minus 1 factorial ways, n minus 1 factorial ways. So, that is nothing but n minus 1, 4 minus 1 here, 4 minus 1 is equal to 3 factorial way. Whereas, if the clockwise and the anti-clockwise are not distinguished, if the clockwise direction and the anti-clockwise directions are not distinguished, then the number of circular permutations of n objects is equal to n minus 1 factorial divided by 2. So, first one is n factorial, that is n minus 1 factorial. Another one is n minus 1 factorial divided by 2. These are the two formulas which are used in circular permutations. Now, let us take an example. The number of ways 8 persons can be seated at a round table. 8 persons. How many persons are there? There are 8 persons. So, 8 persons can be seated at a round table in n minus 1 factorial ways. That is nothing but 8 minus 1 factorial, that's equal to 7 factorial ways. 7 factorial. 7 factorial means simplify this. That's it. Okay. Now, next, the number of ways 10 different stones be set to form a necklace. 10 different stones, the number of ways 10 different stones can be set to form a necklace is Here also n is equal to 10. So the number of permutation is equal to n minus 1 factorial divided by 2. So what is n minus 1? 10 minus 1 divided by 2. 10 minus 1 is 9 factorial divided by 2. So here it is 10 minus 1 factorial divided by 2. That is nothing but 9 factorial divided by 2 will give the required permutation. That's it. Okay. Now, let's move on to the next problem. Find the number of ways in which 8 men be arranged around a table so that 2 particular men may not be next to each other. Find the number of ways in which 8 men can be arranged around a table. So, 8 men can be arranged around a table so that 2 particular men may not be next to each other. Now, how to solve this? Here, how many members are given? So, number 8 men can be arranged around a table so the 2 particular men cannot be next to each other. Okay. Now, very simple concept here. So, how to find this? Very simple. Just find out the total number of permutations. So, this is very simple concept. So, to find the number of permutations, 2 particular men may not be together, means just find out the total permutation minus the number of permutation with 2 persons, right? So, just find out with first. Let me write the formula for this here. The total number of ways so that 2 particular men, 2 men cannot be next to each other is equal to total permutation minus number of ways 2 men together. That's it. So here just find out the total permutation minus total number of 2 permutation with 2 persons together. If you subtract, you will get the required permutation. That's it. Now, what is the total permutation first? Now, the required permutation is equal to the total number of permutation minus number of ways 2 men sit together. So, the total permutation is equal to 7 factorial minus, so the number of ways 2 men will sit together is always, this is equal to 6 factorial into 2 factorial. So therefore the required permutation is equal to total permutation is 7 factorial minus 2 persons will sit together is 6 factorial into 2 factorial will give the required answer. That's it. This is the required answer. That's it. Very simple concept. Just find out the total permutation minus the permit to get the particular men may not together, means just find out particular men be together and subtract, you will get not together. That's it. Okay. Subtract together with total permutation, you will get not together. That's it. Now let us move on to the next problem. Find the number of ways in which 15 staff members can be seated around a circular table for a meeting if vice principal and the dean have to be either side of the principal. So here find the number of ways in which the 15 staff members can be seated around a circular table for a meeting if the vice principal and the dean have to be on the either side of the principal. Dean and the vice principal will be on either side of the principal, right? Very simple concept. Now here vice principal, dean and the principal can be vice principal, principal, and the dean can be arranged in 3 ways. That is nothing but 3 factorial ways. First, vice principal, principal and the dean can be arranged in 3 factorial ways, right? Then how many are remaining? The remaining 15 minus 3, 12. The remaining 12 staff members can be arranged in 12 factorial ways. So, principal, vice principal and dean can be arranged in 3 factorial ways, and the remaining staff excluding principal, vice principal and the dean, 15 minus 3 is 12. 12 can be arranged in 12 factorial ways, right? Now, just multiplied. So, therefore, the total permutation, therefore, the number of ways in which the staff members can be seated according to this condition is, therefore, the total permutation is equal to 12 factorial into 3 factorial. That's all. The total permutation is equal to 12 factorial into 3 factorial. That's it. Just find out the number of permutations of principal, vice principal and the dean, that's equal to 3 factorial, and the remaining staff members 15 minus 3 is 12 can be arranged in 12 ways. Therefore, the total arrangement is 12 factorial into 3 factorial. That's it. Now, move on to the next problem. Now, what is the next problem? In how many ways 5 boys and 5 girls can be arranged in a circle if no 2 girls are together? So, how many boys here? Number of boys is equal to 5, and similarly number of girls is equal to 5. So, in how many ways 5 boys and 5 girls can be arranged in a circle if 2 girls are together? So, 5 boys and 5 girls can be arranged in a circular form so that no 2 girls are together. Okay. Now, just first arrange 5 boys. 5 boys can be arranged in a circle. Boys in a circle can be arranged in a circle, that is 5 minus 1 factorial, that is equal to 4 factorial ways. So, first arrange 5 boys in a circle, that is 5 minus 1, that's equal to 4 factorial. So, the remaining 5 girls can be filled in the remaining gaps. That's it. Now, just arrange the girls in the gaps. So, here we can arrange the boys in 4. B1, B2, B3 and B4. Right. B1. So, in the gaps we can arrange G1, G2, G3, G4 and G5, the girls, like this. So, therefore, in the gaps we can arrange the girls in 5 factorial ways. That's it. Now, multiply these two. If you multiply, what is the answer you are going to get? So, therefore, the required permutation is equal to 4 factorial into 5 factorial. That's it. Okay. Follow. See, very simple. So, 5 boys can be arranged in a circle in 5 minus 1. That is nothing but 4 factorial ways. So, the remaining 5 girls can be arranged. Just assume this is a circular permutation, right? They can be arranged. So, in these gaps, we are going to arrange girl 1, girl 2, girl 3, girl 4 and girl 5. So, like this, 5 arrangement, 5 factorial ways. So, therefore, the required permutation is equal to 4 factorial into 5 factorial is the required answer. So, therefore, the required permutation is equal to 4 factorial into 5 factorial. That's it. Very simple for 2 marks. These are all examples for 2 and 3 marks. Now, let us move on to the next problem. In how many ways 10 beads, in how many ways 10 beads of different color be strung into a necklace if red, green and yellow beads are always together? So, different 10 beads. In how many ways 10 beads of necklace if red, green and yellow beads are always together? Now, consider this red, green and yellow as one unit. Consider red, green and yellow as one unit. All these 3 as one unit. So, therefore, the required arrangement is equal to 3 factorial ways. So, therefore, the required arrangement of red, green and yellow is 3 factorial ways. Now, and the remaining 7 and 1 unit can be arranged in the remaining 7 and 1 unit can be arranged in 7 factorial into 1 factorial, that's equal to 7 factorial, right? So, therefore, the total required permutation is equal to, therefore, the required permutation is equal to 7 factorial divided by 2 into 3 factorial, n minus 1 factorial. So, that is 7 factorial divided by 2 into 3 factorial. So, this will give the required answer. That's it. Okay, if you simplify, you'll get the answer. Okay, that's it. See here, very simple problem. For 2 marks, in how many ways can 10 beads of different colors be strung into a necklace if red, green and yellow beads are always together? So, let us consider this red, green and yellow beads as one unit. The required permutation will be in 3 ways. So, therefore, the remaining 7 beads and this 3 unit is nothing but 1 unit can be arranged in 7 into 1 factorial. So therefore the required permutation is equal to n minus 1 factorial by 2, that is 7 factorial divided by 2 into 3 factorial. That's it. Now move on to the next problem. The problem: in how many ways can 6 gentlemen and 4 ladies be seated round a table so that no 2 ladies are together? Now in the problem there are 6 gentlemen and 4 ladies are there, right? 6 gentlemen and 4 ladies. So there are 6 vacant places between the 6 gentlemen. So these vacant places can be filled by 4 ladies. So 6 vacant places can be filled by 4 ladies in 6p4 ways. That's all. So the 6 vacant places by the 6 gentlemen can be filled by 4 ladies, that is in 6p4 ways. So therefore this is the first arrangement. So in a circular permutation means, so here this is circular permutation. 6 gentlemen can be arranged in n minus 1 permutation, that is n minus 1 factorial, that's equal to 5 factorials. Okay. So that is 6 gentlemen can be permuted in n minus 1 factorial, means 6 minus 1 factorial, that's equal to 5 factorial. Now what is the required answer? Therefore the required answer is nothing but just multiply these two, that's it. Okay. So therefore the total number of ways, so therefore the total number of ways, is equal to 5 factorial into 6p4, that's it. So if you simplify, you will get the answer. Okay, that's it. That is, yeah, the 6 vacant places between the 6 gentlemen can be filled by these 4 ladies in 6p4 ways, and 6 gentlemen can be arranged in 6 minus 1 factorial, that is n minus 1 factorial according to circular permutation. So therefore the total number of ways of the arrangement is 5 factorial into 6p4 will give the total answer. Hope you followed. So these are few problems based on a circular permutation, right? So these are very important problems for the point of examination. You may expect 1 or 2 questions for 2 or 3 marks from these circular permutations. So that's all regarding today's session. Let us meet with a different concept in the next session. Thank you very much.